Hello everyone, I hope your week is going well. Uh, Last couple videos have gotten longer and longer, so I'm going to try and break that pattern here. Let's see if we can't make this one short and sweet. So this week is more applications of the derivative. So in the book sections, that's 4.3, 4.4, 4.5, and 4.7. 4.7? Yeah. So those are the ones we're going to want to look at. This looks like a shorter week, but there's actually quite a bit of material buried in those. So only 4 sections, but they do bounce around a lot, so don't put it off until the last minute. Essentially what you're going to be doing is kind of a continuation of last week, just with a little more complicated stuff. So we have our derivative, and the first thing we're going to look at, and this is 4.3 and 4.5 really too, is how the derivatives affect the shape of a graph. So what we're going to do is we're going to take a function, we're going to take its derivative, and we're going to see, okay, if I look at the derivative, what does that tell me about how this graph has to look? And essentially, the derivative is just the slope. So that's what we're going to look at. So if we have a derivative and it's positive at a certain point, we know that the slope's going up. If the slope's going up, then the graph is going up. So if the derivative is positive, that means that our function, so again, function and then derivative, so if our derivative is positive, the function is increasing at that point. If our derivative is negative, that means we have a negative slope in our function, and so that is going down. So if our derivative is negative, then the function is decreasing. Now we can go one step further and we can take a second derivative, and that tells us about something called concavity, which basically concave up looks like this. So concave up like a cup, concave down like a frown. That's usually how I remember it. So we can talk about the concavity as well when it comes to the second derivative. And so you'll see these things listed as like the first derivative test and the second derivative test. Really, all those tests are is just saying, okay, where's this function increasing and decreasing? Where is this function concave up and concave down? And we do that by checking to see where the first derivative is positive or negative and where the second derivative is positive or negative, respectively. All right, that's 4.3. 4.5 is taking everything you did last week plus that and starting with the equation of a line and just saying, all right, what does this look like? And so you have to find local mins and maxes. You have to, that means finding the critical numbers. Right, you have to figure out where the graph is increasing and decreasing. You have to figure out the roots of it. So basically taking all the knowledge you have up to this point and figuring out what a graph looks like. So that is 4.5. 4.4 is a little bit different. So 4.4 is L'Hopital's rule, which essentially is a nice way to evaluate limits. So when you read it, it's going to look like La Hospitals, but it's pronounced L'Hopital. And so when you have a limit, there is a chance you get what we call an indeterminate form when you evaluate it. And that is either infinity over infinity, positive or negative, or 0 over 0. And so if you end up with either one of those, you can use L'Hopital's rule to help evaluate that limit. And essentially what it says is if you have a fraction and you get infinity over infinity or 0 over 0, you can take the derivative of the top and the derivative of the bottom separately, right? Make a new fraction and then evaluate the limit on that. And so that is how we'll evaluate those limits, is by taking the derivative of the top and the derivative of the bottom separately, putting in a new fraction and evaluating that out. Now we can also use that to evaluate some other indeterminate forms like infinity minus infinity or infinity to the 0 or different things like that. And so you'll see there's a trick to each one of those. So pay special attention when you go through the examples and see what the trick is, as far as all of those are going to boil down to, for the most part, getting it into a fraction form and then trying to use L'Hopital's rule. So pay special care to what the tricks for each of those situations are and see if you can work on identifying when you need to use each of those tricks. But it all boils down to that rule L'Hopital's rule, where we take the derivative of the top and the derivative of the bottom if we have one of those indeterminate forms. So it has to be infinity over infinity or 0 over 0 in order to use L'Hopital's rule. We can't just do it if we get like 5 over infinity or something like that. So it has to be one of those two indeterminate forms. The last thing for this week is basically related rates on steroids, and that's called optimization. So optimization is looking at how big something will end up being, or reversing that, what is the minimum value it will take, but kind of in word problem scenarios like we did with related rates. So what we're going to do for those is it's going to be very similar to what we did in 3.9 with related rates, but instead of having just one equation, we're going to have two equations. And you're going to have to find some way to combine those two equations, and then you're going to take a derivative and find a maximum value or a minimum value. Right? So you're going to have two equations, maybe something like the area of a circle and the circumference of a circle. Right? So you'll have two things that are related. You'll smash those into one equation. Let's say we wanted to maintain a certain area, but we wanted to have a certain circumference, or if we have a square, right, we have a perimeter of 200, and we want to find what's the biggest area we can have if we make a square or rectangle with a perimeter of 200. And so what you'll do is you'll take whatever you want to maximize, you'll let that be the equation. You'll try and sub in the other stuff that you know by substitution. So it's kind of like a system of equations kind of deal. And then you'll take the derivative, set it equal to 0 to find the local min or max, right? And then go about it that way. So when I say it out loud, it sounds way worse than it actually is. When you do the first couple problems, it will seem way worse than it actually is. The biggest and most difficult thing about these problems is finding those two equations and figuring out what to sub where. So again, when you go through the examples, pay special attention to that. Try and figure out what you need to sub where, what are the two equations that are going to relate to things, and draw a picture. A picture will help immensely. So draw a picture whenever you get to these. Look at what two equations you want to use, and look at the examples, right? The examples will be good both in the book, in Paul's online math notes, and you can go to Khan Academy, and optimization is one of those things that is very tricky when you start out, so there are probably a ton of videos on YouTube and various resources that you can look at there. So look at some examples, watch some other people do examples, and see if that helps out, kind of figuring out what you need to do. But that's essentially the roadmap you want to follow. You want to draw a picture, you want to find two equations that relate what you're looking for, you want to combine those equations somehow, take a derivative, and find a max or a min. That's basically it. So watching examples can help with that. Other than that, we have our test upcoming at the end of this week, and so that will cover everything from this week and the previous week as well. So of course, if you run into any issues, please feel free to contact me. I'd be happy to help out. I've heard from literally no one, so I'm going to assume everything's going great. If it's not, then please, for the love of God, reach out so I can help. That's exactly and the only reason why I'm here. So otherwise, y'all have a great week, and I will talk to you soon.